Hello guys, welcome back to my Chem Corner. From this video onwards, we will be doing some of the ncert questions which are behind the chapter chemical bonding and molecular structure. So moving on to your first question that says explain the formation of a chemical bond. Now in this chapter we're dealing with chemical bond, ionic bonding, covalent bonding. We're looking into hybridization. We're looking into Fajan's role a little bit, and we're also focusing on molecular structure, where we are drawing the molecular orbital diagram and all of that. So starting on with the first one, that's talking about the formation of a chemical bond. So before you know how a chemical bond is formed, it's important that you know what a chemical bond is and how is it forming. So chemical bonds form when atoms combine to attain a more stable electronic configuration. Now, why are these atoms going to combine and why do they form a chemical bond? The reason is because they attain a more stable electronic configuration. Now, what do you mean by that more stable electronic configuration is when you look at the electronic structure of each of these atoms, their outermost shell is not complete. By complete, what we mean is they should have 8 electrons in the outermost shell. Now that is not present in case of most of the atoms. Therefore, they are going to combine and then complete that outermost shell, which is also called as a valence shell. So what is the driving force behind bond formation? Anything that happens in chemistry, there is a driving force for it. So the driving force behind the bond formation is the tendency to achieve a more stable electronic arrangement. Now, how is this bond formation taking place? There can be two types, which we will be focusing more on in the chapter. One is when atoms are transferring electrons completely, when a metal is donating its electrons completely, then the type of the bond formed is an ionic bond. Now, when there is a mutual sharing of electrons, this happens mainly between two non-metals. When you have two non-metals, of course, there is a bonding. But how does the bonding take place is there is a mutual sharing of electrons. And when there is mutual sharing of electrons, the type of bond formed is a covalent bond. Now, this depends on their properties and differences in their ability to attract an electron, which is also called as electronegativity. Now, how do you decide which elements will undergo an ionic bonding and which elements undergo covalent bonding? Completely depends on their property. For example, if I'm going to take about ionic bonding is formed between a metal and a non-metal. So what happens here? The metals are readily giving away the electrons, and who's taking those electrons? It is the non-metal. So non-metals accept these electrons and metals give away. So here what is happening? There is a complete transfer of electron from a metal to a non-metal in case of ionic bonding. Whereas as I told you in case of covalent bonding, because it's happening between two non-metals. For example, if I'm taking a hydrogen sulfide, there you have a covalent bonding. That means you have a hydrogen and sulfur. Both of these are non-metals. So the type of bonding that you see in between them is a covalent bonding, which means mutual sharing of electrons. So hydrogen shares its electron, sulfur also shares its electron, and therefore you have a covalent bonding. So that is why we say that it completely depends upon their properties, whether they are non-metals, whether they are metals. Do they have the ability to transfer electrons? Do they have the ability to accept an electron? Those come under properties. Now, difference in their ability to attract an electron. Only non-metals have an ability to attract these electrons. Therefore, they have the property of electronegativity. So, keeping all these in mind, we can say that a chemical bond formation can take place. So, as I told you, we will be focusing more on ionic and covalent bonding in this chapter, along with a few smaller topics and molecular orbital theory.